Hello everybody, hope you're doing well and thanks for joining us for another video. Today I'm going to be tackling a common flat earther claim that the stars in the night sky prove we're not on a globe orbiting the sun. For example, I often see this meme posted saying, if you don't understand that we would see 100% different stars here than we do here, then I'm not sure I can help you. Now, Brock loves posting this meme, though what I find quite amusing is he doesn't just repost the same meme over and over. It seems this meme has been remade a couple of times. We have this one, which is near enough identical, except the Earth is now different colours to denote the seasons. There's a different Earth and Sun on this one, but everything else is the same. Different everything here, apart from the text is exactly the same and the positions of everything are identical. And this one looks almost identical, but it's being credited to an Instagram account called NASA's Deceptions. Why not just have the one version and stick with it? This looks like the Porsche designers have been put in charge of updating the memes. But to be clear, this is not just Brock spamming this one. Trevor Long reposted it, claiming, we see the same stars because they are sticker stuck on Earth's firmament as they rotate east to west. Regardless of perspective, all the way around, completing a full circuit loop, the south can't see Polaris from such a distance and the firmament slope blocks it as well. Not entirely sure how he thinks the slope of the firmament is supposed to block your view of the highest point. That's like sitting near the edge of a giant tent and expecting to see the peak in the middle appearing nearer the ground. But then also, why can't we see the Southern Cross from the north, given that the angle of the firmament slope would be getting less, not more? But I'll come back to this meme at the end, because his claims here will get a whole lot more relevant. Ghost Gone presented another variation of the meme saying, go ahead, present your basic reasoning and vision. I can't wait to be a glober again. The Twilight Dome thankfully posted a completely new version of it, but arguing the same point, claiming the Earth is the center and does not move, and asking why don't we see different star constellations every 3 months. Now, firstly, I'd like to take a moment to appreciate the irony here. Flat earthers are using lights in the sky as evidence for the shape of the ground. And yet, if you bring up the 24-hour Antarctic sun or ask them how people in Australia, South America and South Africa can all look south from their position and see the same stars rotating around an axis, and ask them how does that work on their model, the response is typically along the lines of,
when you look up into the sky, you can't determine the shape of the ground.
The only evidence that they have of the shape of the ground is the sky. Does that sound like it makes sense to you?
Can we agree that the sun doesn't prove the shape of the ground?
Why are we looking at the sky to prove the bloody ground? Prove the shape of the ground. You're looking at the sky to prove what you're standing on.
So the stuff going on in the sky does not change the shape of the ground that you're standing on.
Nothing in the sky is going to prove to you what the shape of the Earth is, Peter.
When you walk outside, you look at the stars, you see a hemisphere, right? So that has nothing to do with what the shape of the ground is, because you're in just one little flat spot of your little territory on Earth.
They are attempting to claim that the motion of a light in the sky overhead somehow gives proof of the shape of the ground underfoot.
Seems lights in the sky are only valid for telling the shape of the ground when they think it fits their model or it debunks the globe. Well, unfortunately for them, I think we're about to add this argument to that list of it doesn't tell you the shape of the ground, because the reality is that we do see different stars exactly as the globe predicts we should. Now, I do have to give some credit to them in their assessments of the globe predictions. They're quite accurate. The issue is their perception of how that applies in reality. They're thinking of geometry two-dimensionally in a three-dimensional world. But to be fair, it's difficult at times to understand concepts without being able to properly visualize them. That is one of the reasons I love today's sponsor, Brilliant.org. They are one of the best online learning platforms around. I've been using Brilliant now for about 3 years, and they've always been great, but recently they've got even better. Much of the homework that my kids get these days from school is online stuff where you can either just keep blind guessing the answers until you look out and get it right, or you can get AI to answer it for you. This is where Brilliant's new Koji feature excels. For example, I've just loaded up a class here on Brilliant, which is called Comparing Rates, and it gives me a table here with some increasing numbers and a few different options. But then there's a little Koji emoji at the bottom. Now, if I was, say, unsure about this, I could say, how do I work out how fast the shapes are increasing? And then it will answer this for me. But what I also like is the fact that it's drawing on the screen to highlight where I need to be looking. And if the answer that it gives you the first time still isn't clear, you can re-ask it in a different way. It's like having your own one-to-one tutor without actually needing a one-to-one tutor. Try Brilliant's tutor feature for free today by clicking the link or scanning the QR code on screen. You can unlock all their courses with a premium subscription, and viewers of this channel can get 20% off by using my link brilliant.org/Dave McKeegan. So let's first get a clear understanding of what flat earthers are claiming. Now, I saw this video from somebody on TikTok demonstrating the same argument.
And so here we are, January 1st, right here. And when it's daytime, we're looking at the sun. The sunlight is coming from here. So the sunlight is lighting up the earth this way. And then when it's nighttime, you're looking out this way. You're looking out at outer space this way, okay? And so you're seeing the stars that are out here, this direction, because it would be impossible to see the stars over here because you got the sun in the way, right? Okay. All right, now it's springtime. So we're over here. And now that it is springtime, say April 1st, and we're looking at the sun, daytime, we're looking this way, and then at nighttime, we're looking that way. All the stars at this side of the universe. And now let's go a full 6 months. So it's like July 1st, June 1st, July 1st, now we're on the other side of the sun, right? And so daytime, it's lighting up this, and then it goes over to nighttime. Now you're looking at that side of the universe, right over here.
So he is mostly correct in his hypothesis that 6 months later you would be on the opposite side of the sun, so would be able to see a completely different part of space, thus star patterns should be different.
So it should be all new stars, right? All new constellations. No, it's not. The same stars, constellations, and planets that you see over here 6 months later are the exact identical stars, constellations, and planets.
Which isn't actually the case, but they're seemingly failing to factor in that the shape of the globe is three-dimensional. For starters, anywhere on the globe, assuming you have an unobstructed view of the horizon in all directions, then you're actually seeing basically half the celestial sphere. As you change location, the stars that are visible within that half are gradually changing. So, if we have this person on the Earth looking straight up, they would be seeing half of the star field. And if somebody else was on the opposite side of the Earth, they would be seeing a completely different star field. Then if we rotate the Earth 180 degrees, like it being on the opposite side of the Sun, the first person would then be seeing the second person's star field, thus a completely different set of stars than they were viewing 6 months prior. However, that logic doesn't actually work for most places on Earth, because if I had these two people standing at the North and South Pole, they would then be standing on the Earth's axis of rotation. They would still see completely different star fields to each other. However, we wouldn't expect their visible star fields to change over the course of 6 months. Ignoring for a moment that the sun would obstruct their view of the stars for periods of the time, if at one point in time the two people both look towards the left side of our screens, they would see particular star patterns. 6 months later, the Earth is on the opposite side of the sun, they could still look towards the left side of our screens and would still be looking towards the exact same stars. The people at the North Pole wouldn't see the stars in the southern hemisphere sky, or vice versa, i.e. they won't see the Southern Cross from the North Pole, and people in Antarctica wouldn't see the Big Dipper, because the Earth isn't rotating along the right axis for that to happen. So this notion of seeing completely different stars at different times of the year only works for people who are standing perpendicular to Earth's axis of rotation, i.e. along the equator, which is easy enough to test just by looking at Stellarium. Go to a location on the equator, set the time at around midnight so the stars are all clearly visible. This is what people at this location would see on July 31st. Now if I roll the date 6 months to January 31st, completely different star field, just like flat earthers argue we should see. Though the completely different stars are mainly the ones up and overhead, not near the horizon. People at the equator can still see the celestial poles, especially if they're at a high enough elevation they can see both celestial poles at the same time. Because at a high elevation the horizon is below your horizontal, so there will then be a slight overlap between the half of the sky that you're viewing 6 months later. Flat earthers often bring up the Big Dipper as an example that the stars don't change. They argue you can see the Big Dipper all year round, except you can only see the Big Dipper all year round from the northern hemisphere. People in some areas of the southern hemisphere never see it, or at most they only see part of it. The Big Dipper is part of the Ursa Major constellation, with the northernmost point of it being only around 25 degrees away from Polaris. So for people in regions like North America and Europe, when they're looking at the Big Dipper, you aren't really looking straight up at it, you're looking to the north to see it, which means on a globe you're sort of looking in this direction. And that direction is visible no matter which side of the globe you're on at that latitude. So sure, for people in North America or Europe, the Big Dipper always becomes visible at some point during the night regardless of the time of year. However, if we look at an observer location, say, down in southern Chile or Argentina, only part of the Big Dipper is actually visible and it only occurs at certain times of the year. 6 months later, it's not visible at all. It's like if you were to sit on a spinning office chair. You can spin around whilst looking up at the ceiling and you will see an axis of rotation directly above you. Look down and you'll see another one on the floor, just like the two axes of rotation that the globe has. If you sit on the chair bolt upright, that is like somebody standing on the equator looking straight up. You can see both axes of rotation, but they're at the very limit of where you can see. And between those axes, you see an entire half of the room. But then if you rotate 180 degrees, you can still see the two rotation points, but the half of the room that you can see in between them is now completely different. But if you lean the chair back, this is more like somebody in the northern hemisphere. Now, the northern point of rotation is easier to see, and you can even see bits of the ceiling beyond it, but you can no longer see the rotation point below you, i.e. the south celestial pole. Now, when you rotate 180 degrees, the bits of the room lower in your vision will look completely different, i.e. the parts of the sky when you're looking south, but you can still see much of the same parts of the ceiling because of the overlap. The only difference is the patterns on the ceiling now appear the other way round, which fits what we can actually see in the night sky. If I go back to Stellarium, and I'll place my observer location around London at midnight on August 28th. Ursa Major is close to the horizon in the north, with its shape orientated so that its feet are nearest the ground. But if I jump forwards or backwards by 6 months to midnight on February 28th, still looking north, Ursa Major now appears on the other side of Polaris with its feet sticking up in the air. However, if we compare the views looking south, just like dropping your chin slightly on the tilted office chair, well, from London at midnight on August 28th, these are the stars that we can see. And this is February 28th, 6 months apart, and they're completely different stars. For example, in February, looking straight south at midnight in London, you can see Rho Leonis at around 47 degrees altitude. 6 months later, you can't see it at all. It sets over in the west in June, and it doesn't reappear again until mid-November when it rises in the east. In August, 6 months later, it's not visible. By which I don't just mean it's not visible from London, I mean it's not visible from Earth. Because in August, it's near the sun in the sky, which you can verify by taking where it's placed in relation to the rest of the stars in the celestial sphere and seeing what stars are visible from where just before sunrise or just after sunset from various locations around the world, and you will find that puts this star's location around the sun. Just like flat earthers say should happen in the heliocentric model when 6 months later the Earth is on the far side of the sun. And it's the same basic thing with the every 3 months argument. Let's consider what the globe would actually predict, because memes like this are showing you only having a narrow viewing angle when looking out into space. Again, in reality, what we see is a full hemisphere of the sky, so a full 180 degrees from side to side. If you sit on your chair in the middle of the room, aiming square at one wall, which would be like looking straight up at the equator, you can turn your vision 90 degrees either way and see the adjoining walls. If you turn the chair 90 degrees, which would be like in the heliocentric model 3 months later, you're now looking square at the next wall, which you could already see before when you were looking sideways. And the wall that you were previously looking at is still visible, but now it's 90 degrees to the side. So the stars that were near the horizon 3 months before would be overhead, and the ones that were overhead would now be near the horizon 3 months later. Which, no surprises, is what we actually observe. If I pick a location on the equator, look straight up and highlight any star that is directly overhead, then I jump back 3 months, I can see that star was near the horizon in the east. And if I skip to 3 months afterwards, it's now near the horizon in the west. And that is the case for any given date and any location on the equator. Pick anywhere on the equator you want, any time of the year that you like. Look straight up and pick any star that is directly overhead. 3 months before that chosen date, it will be in the east. 3 months later, it will be in the west. Exactly as is to be expected with the heliocentric model. And for anybody who thinks, oh, well, that's just a computer program telling you that, you can't trust it, simple test is pick any location on Earth, any date in the future you like, and see what stellarium predicts you should see, and go there on that date and time in question and see. I've done that numerous times myself over the years, and never once has it been wrong. Now, I am curious about flat earthers' responses to this, because all these posts are saying, well, if the Earth's a globe, we should see completely different stars in the night sky 6 months apart. They think we don't, therefore the Earth's flat to them. Some flat earthers even calling it a big red flag for them against the globe.
There's certain things that just resonate with certain different people, like different points. Like for me, I see what you're saying, but like for me, the star thing is like bing, 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 bing.
Oh, yeah.
Red alert, red alert. Like that is, to me, the one that is like, there's clearly something wrong here with the stars. If we're seeing the same stars all year.
So I'm curious, given that this claim was such a big turning point for some flat earthers against the globe, now having seen that actually the observations in the sky perfectly match the globe, especially at the equator where it exactly fits exactly what flat earthers themselves say we should see if the Earth's a globe, will they now say, you know what? I fell for flat Earth because I thought the observations of the stars didn't match what we should see on the globe. And actually we do see different stars throughout the year like the globe predicts, therefore maybe the Earth is a globe? Or will they say Earth's still flat and actually the flat Earth model predicts we should see the stars changing throughout the year just like this anyway? My money is personally on the latter, since that's what they did with the 24-hour sun in Antarctica. For many years, flat earthers, when talking about the prospect of a 24-hour Antarctic sun, made the prediction there wouldn't be one, and that the existence of one would be a massive problem for flat Earth.
This midnight sun phenomenon must also occur for observers south of the Antarctic Circle during winter solstice. Depending how far south the observer is, the sun should be seen for several days or weeks, never fully setting, just like it does in the north. In reality, however, there is never 24-hour sunlight anywhere in Antarctica at any time of year.
yes, there is no 24-hour sun in Antarctica. Let's just get that straight.
One of the arguments that people give is on a flat Earth, you can't have a 24-hour sun, a midnight sun in Antarctica. And I totally agree. But there is no midnight sun in Antarctica.
In the flat Earth model, we say there isn't a 24-hour sun in the south, and there isn't.
To clarify, we know that you can get daylight, sunlight, but you don't see the sun in the sky for 24 hours. On a globe, it needs to be the sun's in the sky for 24 hours.
Let me and you go to Antarctica, spend a week there in the summer, and let's see if the sun does a 360-degree circle all the way around us. If so, it's a ball.
All right, we've got Flatsuit. Are you willing to publicly admit you were wrong about flat Earth if we see a 24-hour sun in Antarctica this December?
Yeah.
Then fast forward to 2025 after I'd been there and recorded that it exists, and suddenly flat earthers were saying that the flat earth predicted one all along. So just in case any of them are now preparing to say, well, actually a flat earth predicts these changing star patterns as well, let's bring ourselves back to that post I showed at the beginning from Trevor Long. Quote unquote, we see the same stars because they are sticker stuck on Earth's firmament as they rotate east to west, regardless of perspective, all the way around, completing a full circuit loop. So let's imagine for a moment that the stars are stickers on the firmament and that the whole firmament is rotating above the Earth. Stars around the North Pole staying the same all year round, just like the globe. Yeah, okay, that's feasible. Stars at the equator changing throughout the year, just like the globe. Okay. However, the further south you go, the stars should then be changing even more than at the equator. People in South Africa, South America, Australia and New Zealand should be seeing even more drastic changes to the star patterns every 6 months, whereas the globe predicts that the people in the south should basically be seeing a mirror of what the people in the north are seeing at the same latitudes, i.e., the star patterns all year round near the celestial pole stay the same, but the visible stars through the month change when you're looking in the opposite direction, which is exactly what we see. So the star patterns not only match the globe, they go against Trevor's ideas of stickers on a firmament over a flat Earth. Does that mean Trevor's going to change his mind about the shape of the Earth now? I mean, GhostGone even said they couldn't wait to be a glober again, so presumably they'll be changing their mind. Well, on that note, I'll say, as always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please do consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.